Morning to one and all present here. We are very glad to inform you that our college, Union Christian College Aluva, is celebrating 100th anniversary in this academic year. As a part of our centennial celebration, our Department of Electronics and Computer Maintenance is organizing an international webinar today on the topic Blockchain Powering the Future. Now I take it as my duty to welcome each one of you to today's webinar session. Primarily, I express my hearty welcome to Reverend Father Thomas John Father to today's webinar session. Next, it's my extreme pleasure to welcome our Principal Dr. David Thatch Matthew to today's program. And today, our resource person is Mr. Prabit Balagopalan, Associate Consultant TCS, Sydney, Australia. Mr. Prabit Balagopalan is currently working as Enterprise Solution Architect with TCS. Prior to joining TCS, he had worked in another major companies like CTS and UST Global. He is well experienced in software application development using core Microsoft technologies. Welcome Prabit for your presentation. Next, I would like to invite our HOD, Mr. Agil TV, for today's session. And also, so many students and faculties from various institutions are attending today's webinar. Welcome you all. Now we can start our session. So before our session, I request all of the participants to mute your microphone and turn off your camera. Thank you.
Hello, Prabit. Please unmute your microphone?
Okay. Good morning and good morning all, and thanks for joining my session today. And at first, I would like to thank Mr. Akhil sir and Milama for giving me such a good platform. And I express my thanks to the principal, manager, and Reverend Father, for giving me this opportunity. So the session I'm planning to take today is blockchain. So when Milna ma'am asked me to take a session during this lockdown, to take a session for all the college, UC College Alva students. So I was looking for a topic, but immediately that came into mind was blockchain, mainly because it's one of the hot topic in the market as of today. Because it's still in the earlier state of maturity. It's still maturing technology, and a lot of people are investing money and effort into this platform. There are a lot of business value inside, and also as a Department of Electronics, there are a lot of things for you to also do study on. Since it's in a quite initial state, there are a lot of chances, there are a lot of possibilities you can explore and you can contribute. So I was planning to take this session. I'm not an expert in blockchain technologies, but just like others, I'm just following up with whatever the latest inventions or inventions on blockchain. I'm keenly following or an enthusiastic blockchain evangelist. So if you are well known to the term blockchain, then it's good. You can think in a different angle once you go through this webinar, or if you are pretty new to the term itself, the blockchain term itself, something you can take it from here. So my main intention of this webinar is not to teach anything, but just give an insight or give a walkthrough on the blockchains. So if you're not familiar, maybe I know as a smart students, you will have a lot of interest, or you have a lot of capability or potential to explore it, and maybe I don't know, probably you will be the one who is giving such contribution to the blockchain technology tomorrow. So there would be a lot of things. I mean, you can explore it once you go through this webinar. So being said that, let me start my presentation. I'll start with a presentation which is like boring to you, some definitions, and we'll slowly will try to dig more. I won't be taking a deep dive into blockchains, but giving a walkthrough or giving a high overview in which you can capitalize. You can go through Google and find out more and more if you're interested. But yeah, it's always good to know about this technology. Whenever you like, if you have got a campus placement or anything, you can proudly say that you know the terms or you know the technology. It will always as a plus point for you as students. Also, yeah, this is one of the, I mean, one of the other thing yeah, I could tell is that whenever we are studying, we didn't get such platforms, or you're lucky to have such teachers or such platform or such colleges. Actually, I think I came to UC College Aloha when I was doing a job hunt just after my MCA. There were a lot of sheds, I mean, exams happening in UC College Aloha. I know it is a good campus. I love the campus. It's a green campus, and now I know you got a good platform, the Google Meet. I'm taking a session in Google Meet for the first time. I've taken a session mainly on technical session for my colleagues, mainly on Microsoft technologies, but on a generic topic, and that too with this Google Meet, I'm taking it for the first time. As Nilamam told, I'm working with Tata Consultancy Services, currently on a deputation to Australia. I'm working in banking and finance domain, so working with one of the leading banking client over here. So mainly working as a software architect or enterprise architect, or I'm working as a technical lead mainly on the Microsoft technologies. I do a lot of programming mainly on the C sharp and the mainly on C sharp technologies. So my main strength is like I'm an application programmer as well. So I can when I present this session to you, I brought some I mean, I was planning to bring some programming concepts as well, but since I don't know about your background, then I backed off. So that is why I'll give a overview on the topic. So if you have any questions, you can ask maybe at the end of the session. If I can answer, I can answer it at that time. Otherwise, if I'm not able to answer, maybe I can get back to you. So let me start with my presentation. So I'll start my PPT. Okay. So I have taken this uh, topic. This, as I told earlier, it's a hot topic in the market. Let me start with the basic introduction or the boring definition we see in all the presentations. So this blockchain is nothing but a distributed ledger. You might have seen ledgers when you went to a shop or some I mean some financial institution. They will have some books and they will keep track of all your transactions. For example, if you pay something, they might write something, and if they're selling something, they might kind of debit and credit transactions or anything. So it's kind of the blockchain is a shared distributed ledger that facilitates the process of recording transactions. So when you purchase something, you're making a transaction over there. You're giving some money and getting something in exchange of that money. So basically, you are making a transaction over there. So it's kind of a blockchain. It's a shared distributed ledger. I'll explain why it is distributed ledger maybe in the consequent consequent slides. But let's start with that basic definition. So when I was talking about an asset, so we talked about tracking assets in business network. So an asset can be anything. It can be tangible. I mean, it can be a house, a car, cash, land, or any intangible like intellectual properties such as patents, copyright, or any branding. For example, you're buying a house, you're giving him money, so you're making a transaction over there. You're buying a car or buying a bike, so you're giving him money and you're getting something in return for that money. So that is an tangible asset, and there would be some intangible assets as well. For example, the intellectual property. For example, you're making a video, so it has got an intellectual property. I'm writing a code, or I'm writing a code for my company, so it has got an intellectual property, or it has got a IP associated with that. And there would be some patents. You're inventing something, you're inventing a machine, you need to get a patent so that you can sell that patent. So it's kind of a intangible. The copyrights, that is also intangible. I mean, it's all in digital paper. I mean, digital media. You don't know whether you touch it or it's not. It's intangible. And virtually anything of value can be tracked or traded in a blockchain network. So it actually in the blockchain network, you're tracking all the assets and all the transactions in a distributed ledger manner. I'll explain you why that term, the consequent slide. And the term, the basic of block is nothing but a bunch of transactions that have been added to the blockchain. So there would be a chain of transactions. So whenever you're making something, you're making a transaction, it will be treated as a block. You're adding a transaction into a block and you're putting in the a chain of transactions. So now I'll explain more. Whenever we are talking about blockchain, I mean, there were a lot of perception that we are talking about Bitcoin. Why it is like Bitcoin and blockchain? It's coming as part of maybe two sides of coin, but ideally those are two different entities. Bitcoin's actually it makes use of the technology underlying its blockchain. So never be confused with Bitcoin and blockchain. Bitcoin is not equivalent to Bitcoin. I mean, blockchain is not equivalent to Bitcoin, but it is actually Bitcoin is making use of the blockchain architecture or blockchain ecosystem or blockchain's data structure itself. So you can treat like anything when you're talking about blockchain, but Bitcoin is kind of a byproduct out of that blockchain. And obviously, blockchain it gained the popularity because of the Bitcoin. We're seeing a lot of things in the internet, a lot of things in the newspapers of Bitcoins. I mean, there are Bitcoin transactions happening here and there, and some countries made it legal. And I don't know, India, it is still an illegal. Yeah, but in the internet, if you see Bitcoins are widely used, that's called the cryptocurrency as well. Bitcoin is synonymous for cryptocurrency. And you can think about two things: blockchain and Bitcoin as different things. I mean, blockchain is as a raw gold. I mean, it's kind of gold ore. And on the other hand, Bitcoin, you can think of a jewelry. You're making a thing out of that blockchain. So you're making something out of that blockchain technology itself. So if I thought I'm an application programmer. So then I treat blockchain as a data structure, just like arrays, list. You might have already learned in your classes about many data structures. Would be a boring topic, but yeah, arrays, lists, trees, and you have seen a lot of algorithms out of that. So you can treat a blockchain as a data structure. And what about this cool thing about this data structure? There are two factors. I mean, the blockchain in any the first fact is that a change in any blockchain invalidate every block after it, which means that in case of cryptocurrency, you can't tamper with historical transaction. One block is linked with the other block. So when I talked about blockchain, you can think about blocks in this manner. For example, this is the block and it has got a lot of transaction data. And block two is a different different entity, block 3 is different. Everything is linked with some hash value, cryptographic hash value. For example, it started with the hash 6u9p2. The next block after coming after, this block 1 in the blockchain, the block 2 will have the previous hash of 6u9p2 in that block. So in that case, if you want to tamper that chain of blocks, then it means you need enormous effort to tamper that. For example, you're using a cryptographic, usually the blockchain uses SHA-256 or the SHA-2 algorithm to create that hash value. So in order to tamper that, you need enormous computing power. Or if you have, like, let's say, millions of computers are linked together, then actually you need the enormous computing power. You need enormous power to make that the cryptography algorithm. And in the Bitcoin, there is a concept called Bitcoin itself. The second cool thing is that you only get rewarded if you're working on the same chain as everyone else. So there are some advantages that Bitcoin. I don't want to touch upon detail on Bitcoin because it's totally a different topic itself, and I don't want to touch that. But there would be some, whenever the nodes are participating in a blockchain or Bitcoin network, they will get some out of it, something out of it. So you might be wondering why I took this PPT. You could see that some characters you might be misunderstood with some other scripts, which is our neighboring country. But it's actually basically it's a Japanese script. So I took this PPT or the title or the template actually accidentally, but then I realized that it has some meaning because actually the blockchain was invented by a person. His name, using the name Satoshi Nakamoto, is a Japanese scientist. Someone is saying that it's a pseudonym. Someone is saying it is not a person but a group of people. It was coined during 2008 or 2019. Still unknown about that date, but it's something around somewhere around 2008 2009, mainly coin used in bitcoins at that time. So to serve as a public transactional ledger of the cryptocurrency Bitcoin. So the identity of Satoshi Nakamoto, the Japanese, still remains unknown to the date. I mean, we don't know about that person. But one thing we are sure, he or they are from Japan. So that's why accidentally it became a kind of the template, something to do with Japanese culture. So let me start with the. So I explained blockchain, few of the terms or some definitions, some about Bitcoin. Let me start with the basic video. Uh, I'll I'll play the video. I don't know whether you'll be able to hear it properly. I tried to download the caption, but I unfortunately I haven't got the caption yet. Actually, I downloaded from the YouTube from a Lisk Academy. There are a lot of cool videos. You can go to the Lisk Academy. There are a lot of basic videos. You can go through it. You can understand blockchain. At an extent. So let me play this video. Okay, so that is a cool video, isn't it? So I taken that video from YouTube, and I was looking for a, when I was looking for a small video, some for some reason I like the video, mainly the fact that I can correlate with what the story is talking about. A cool child. I mean, he wanted a blue cat during a Christmas time. He sent a letter to Santa. He actually initially he posed. In that year, he actually posed a letter to Santa asking for a blue cat. He's giving the letter to his father, but on the uh, so he his father is acting as a middleman between Santa and the kid. So during on the way to post office, actually he opens the letter. The father opens the letter. He saw that Jacob is asking for a blue cat, so it looks quite weird for him. So what he did, like he changed that wish itself, and he changed it with a pair of socks. So on that Christmas, on that year, he got a uh, pair of shoes, a pair of socks from Santa as a Christmas gift. So he got disappointed. On the next year, actually, what he did, he used a blockchain. He uploaded his wish to a blockchain technology or blockchain of network. Then he put his identity unknown, but his wish was like public, and he posted into that blockchain network. So it was distributed to all the networks, all the computers in that network. So everyone has got a copy of each one's wish. For example, Jacob is wishing for something, and actually it was put it as a paper or put it as a page in the ledger. And the next page of the ledger, it might be having a wish from a different person like Alice or Anna. They have a lot of wishes. So all the nodes have got a individual copy of that wish list. So even Jacob's parents, they are part of this network. They can see everyone's wish list over there. They just open the wish list, and while searching it, while browsing it, they could see that yeah, someone was looking for a blue cat, and suddenly the thing that came to their mind was, yeah, it is like their son is asking for a blue cat again to Santa. So what they did, like they changed it with a book actually. But when they updated, but all the participants node has got a copy of that record, and they couldn't tamper it. So whenever they see that someone has tampered the network, they they disconnected that node from the parents node from the network. So that is like it's kind of yes kind of representing a blockchain technology. Why I put this video is because I can correlate with my family, because my son actually is very fond of cat or kitten. He was always keep on asking me about or asking us to get a cat or kitten for him. But for some reason, we like for maybe some health reasons, we couldn't uh, fulfill that wish. Probably he might be using it next time. Maybe he might be using a blockchain to get his wish fulfilled. So that's why I could correlate that video with one of my uh, real time example. So that is how it is just a percent. Um, just a representation of blockchain technology, how it is working. I'll explain you the terms one by one in the consequent slides. So whenever you're talking about blockchains, there are some technical jargons were used. For example, we already talked about shared ledger. Shared ledger is nothing but you can think about as a paper in a book. I'll explain later. There are some other share ledger. Then you can see some term like smart contract. It's nothing but business terms embedded in transaction database or executed with transaction. And whenever we are talking about blockchain and the data, we are concerned about privacy, how the data is getting transferred, how that data is visible to all the users. And anyway, there is some one more term called validation. I mean, someone need to validate all this transaction because whenever you're making a transaction, for example, you're paying with a debit card or credit card. So someone is validating your payment. It may be your bank or it may be the card issuer is validating the transaction. So we need some validation mechanism in a distributed system. So that is why I'll take terms one by one. So let me try to explain the jargons. So we already talked about jargons. It's nothing but a system of record for business. So it's kind of a book, the old book where you write all your transaction details. So business have multiple ledgers. For example, even if it is a small shop, they will have multiple ledgers. They are keeping multiple ledgers. So in the shared ledger technology, allowing any participants in the business network see the system of record. For example, we have seen it in the preceding example where Jacob he put his wish list. So everyone can see that wish list, or anyone can see that wish list. So it's kind of a they're keeping in a shared ledger technology. So whenever you're talking about blockchain, it is pointing to a one and only one term, that is a distributed shared ledger technology. So there are a lot. We could see that there are a lot of participants in a business. For example, if you're selling something, there would be n number of participants. There would be vendors. There would be, I mean, who were producing the entities, who are selling. There would be middleman. There would be customers. There will be banks. So it's kind of participants are nothing but a members of a business network. Anyone who has got a stake in that business or in that business network. It can be a supplier, customer, government, regulator, anyone. So usually resides in an organization. So you can think about in an organization. You can think about banks, or let's say you're a shop. Anything can be a participant who has a direct or indirect stake in that. And transaction, I told you, an asset transfer. For example, here you have seen that Santa gives a Christmas gift to Jacob. That's a transaction, and there would be a contract. There would be some contract with any business transactions. For example, here if you see the preceding example, the gift will be given to a Christmas day. That is on 25th of December. That is a simple contract, but you can make the contract more stringent, or you can make it more complex. Like the gift should be suitable to kids. That's one of your condition. You're putting one more condition. That's a contract, and there are much more terms. Ledger I told. Then one of the main concern is about the privacy of the data or the transaction to be private. So in order to make the transaction private, we are using the cryptography over here in the blockchain. So cryptography is the central thing into this all these processes, and we are mainly using SHA-256 or the SHA-2 algorithm to encrypt the transaction and making it more secure. And I told about the contracts. We can add one more term into that: smart contracts. It's nothing but business rules implied by the contract and embedded in the blockchain or executed in the transaction. For example, if you want to execute a transaction, you can make a smart contract. Actually, smart contracts are nothing but a small snippet of programs, small programs written in any language: Python, C Sharp, any language, C++, and it can be triggered with some business rules, and the smart contracts are verifiable, signed and encoded in programming language. So it's sitting in that blockchain network itself. And you need some validation. For example, what you're trying to do is like you're trying to make it as a distributed. I mean, you're keeping the copies in each and every node in your network. So there should be some validation to happen about the transactions. So I'll talk to you about the validation in the preceding slides. So let's check about the current ecosystem. For example, you're going to this is a typical example of a current ecosystem in which there would be a lot of people participating in a transaction. For example, if I want to send up money, I'm currently staying overseas and I want to send some money to my Indian account. So what I used to do, I have a lot of third-party applications or third-party vendors who can transfer money on behalf of me. What they do, like they actually uh, they get the money from my bank account when I give my card details or my bank account details. They take the money. I mean, the bank will check whether I have got enough balance to make that transaction. And this intermediary they will send to some intermediary, and there would be more intermediary. And actually, once it is reaching to my Indian's account or the other account, it may take some time, maybe 1 or 2 days. There are some cases in which you can make instant transfers as well, depending on your technology. So in that case, now the problem is that everyone is keeping the ledgers with them. When I'm initiating a transaction, the third party or the bank they have their own ledgers. They will check all the records, whatever my previous records, previous transactions, my current bank balance, everything they will be checking it, and they will when they are going to send it when it is credited to my Indian bank account. What they used to do, like they value it or they make that they're keeping their own ledger. So the ledger is like kept in all the places, which is not centralized. But the thing is that everything is like through a middleman, or that centralization is there. I mean, you're talking to a middleman, you're talking to an other intermediary, then you're talking to an other intermediary. So when we are talking about blockchain, the coolest thing is that you're talking with each and everyone in an ecosystem. So whenever you're this is kind of inefficient, expensive, and vulnerable. I mean, anyone can get into a system and make the transaction, or they can they can create any havoc in that system. So you can think about a blockchain ecosystem. It's kind of a ledger. You're keeping the copy of the ledger everywhere. So the participants use the multiple shared ledgers, so they can see all the transaction based on the permission level they have. The identity it will be verified. So the ledger is kept in each and every node, whoever participating in the ecosystem. So why I was telling like the example of bank, because the blockchain is going to disrupt the banking technology. That is one of the uh, imminent thing I could think of when we are talking about blockchain, because it will change the way in which banks or the central bank system or whoever participating in a like as a bottleneck, there is a chance that yeah, it will slide, that friction will slightly go down, and they will be like more of a they will take a more of a participant role in a blockchain ecosystem. So for example, if you're in a supply chain management system, you're getting a product from a shop is getting a product from a producer and getting into a shop, and for example they are giving some purchase orders, the purchase order to procure something, and this purchase order they have to raise an incident, they have to raise an invoice, or they have to raise an invoice against a purchase order. So what they used to do, like if you are thinking about a blockchain technology, you can think about all these participants in the blockchain. So whenever you're making a purchase, you're giving a purchase order, you're generating an invoice, then banks can actually they can participate in a blockchain in which they can release some money based on a smart contract. So that is a way the banking sector is also going into, and we have seen that blockchain has been adopted in many of the industries at the moment. Even if you see in India, you can see that the Andhra Pradesh government they have introduced blockchain technology to keep all the land records in the blockchain technology. The the nice part of that technology, implementation is that whenever you want to purchase a land, what you need to do, like you will go to, you will get the documents from that the person who is going to sell the land. You will get it endorsed by a advocate or attorney, and they will validate your document whether your document is valid or not. So whenever you're keeping all these transactions in a blockchain, actually you can do this all this validation in quick time. All your transaction related things, you're selling lands to multiple persons. All this transaction will be kept in multiple blocks, and that will be validated with the participants in that blockchain. So that whenever you want to sell or buy something, you can think about anything. You can think about purchasing a bike itself or a car itself. There would be a lot of participants. So these all this transaction from a producer to the customer, it passes to multiple people. So if you are bringing all those people in an ecosystem, then you can track where your product is or from where it is coming from. You can track all the transaction related to that. For example, you bought a car or you bought a bike and you sold it to someone else. Then you're making one more transaction that can be kept in a blockchain. You can see two transactions, the first purchase and the second purchase, and actually you can validate everything in a blockchain ecosystem. So in the future, the thing is that even the government organization can be part of this blockchain ecosystem. So being said that, I'll touch upon now. You understood that blockchain is nothing but a chain of nodes that is connected by an ecosystem or some protocol in which every participant has a right to validate a transaction. They can see the transaction based on the permission level they have. Now we'll talk about types of blockchains. There are three types of blockchains. It's a broad concept, but yeah, mainly you can treat as three primary types of blockchains. One is public blockchain. Whatever the example we have talked about, Bitcoin, Ethereum, all this an example of public blockchain. And you can see that there are private blockchains, for example, Hyperledger and Arctic are some of the examples. Then hybrid blockchains, which is making use of both public and private blockchain concept. So the main difference between them is mainly how they are included in the network and how they validate transactions and the level of transparency of the transactions. So this is the main idea of categorizing these types of blockchains. So let me talk about public blockchain. So this kind of a public, as the name indicates, it's a public blockchain. They allow anyone to participate as users. There would be users, something called miners. I'll explain the term later. Developers or community members. All transactions that take place on a public blockchain are fully transparent, meaning that anyone can examine the transaction details. And public blockchains are designed to be fully decentralized, with no one individual or entity controlling transaction recorded the blockchain or the order in which they are processed. And the public blockchains can be highly censorship resistant, since anyone in open to join the network, regardless of location, nationality, etc. This makes it extremely hard for authority to shut them down. That is why the Bitcoin is like a bit of controversial, because it is trying to create an alternate system for existing banking or existing monetary system, in which we have got a central. For example, in India, we have got the RBI or the Reserve Bank of India that controls everything. So that's why if we are giving a cryptocurrency, the Bitcoin, much more freedom, then it can disrupt your economy. So that is a Bitcoin. I'm taking it as a separate thing. It's not a block. It's making use of blockchain technology, but it's not block. Uh, that's not our intent to look into this. So lastly, public blockchains allow a token associated with them that is typically designed to incentives and rewards participants in the network. So that is why in Bitcoin network system, whenever the participants associated with that blockchain or the Bitcoin network, they will be rewarded with Bitcoins, and it has got some value as some dollar or currency value it has. So that is the concept of public blockchain. Now we'll talk about private blockchain. It's known as permission blockchains. It possesses a number of notable differences from public blockchains. It actually needs consent to join the network. For example, when I want to join into this Google Meet, what I requested to join into the network. So Agilsar actually allow me to enter into a Google Meet. So in the same way, private blockchain actually you need permission or you need consent to join the network. The transactions are private and are only available to ecosystem participants that have been given permission to join the network. And the private blockchains are more centralized than public blockchain. So it has got that centralization thing. Actually, it got reduced in private blockchain. So it is more of a centralized one. And private blockchains are valuable for enterprises who wants to collaborate and share data, but don't want their sensitive business data visible on public blockchain. So they don't want to show the data to entire public. So it's for the organizations. These chains, by the nature, are more centralized. Their entities running the chain have significant control over participants and governance structure. And private blockchains may or may not have token involved in the chain. I'll talk about one more type of blockchain that is called consortium blockchain. It's not treated as a separate blockchain concept, but actually it's a subtype of private blockchain. So consortium blockchains are sometimes considered as a separate designation from private blockchains. The main difference is that consortium blockchains are governed by a group rather than a single entity. So we've seen that in an organization, there would be some single entity that is governing the blockchain, private blockchain, but it is actually in a consortium. There would be a group of people. They're they're making the consortium more effective. This approach has all the same benefit of private blockchain and could be considered as a subcategory of private blockchains, as opposed to the separate type of chain. This consortium actually can be used in the place where you will see the group of frenemies. For example, uh, let's say two supermarkets, let's say Lulu and Big Bazaar. There are two supermarkets. They're competing each other, but they will have some common interest within them. So it is actually it's for them who actually having that running the same business but competing each other, but they will have some common entities. So this is for them. I mean the consortium, and they are able to be more efficient both individually and collectively by collaborating on some aspects of the business. And participants in consortium blockchains could include anyone from the central banks to governments to supply chain. They can include the governments or the organization as well. And we talked about the private and public and bit of consortium blockchain as well. Now we'll talk about hybrid blockchain. Hybrid blockchain is nothing but it actually mixes up with mixing things of public blockchain advantages and the private blockchain advantages. It can be a public or it can be private. For example, in banks, they offer some their public things to in a website, but they will have internal system to keep track of everything, all the transaction. So it's kind of a hybrid blockchain. Have some water. So it can be actually they can actually have more control on the private blockchain as well as they can make use of the properties of public blockchain. Now we have seen that there are a lot of transactions happening in the blockchain. When you are transferring the money, when you're purchasing something, that a lot of transactions happening in a distributed ledger. You're seeing that the ledger is public. You can see everyone is having that visibility. Now someone needs to validate it, right? When you are making a transaction, for example, when you are making a purchase, usually I told you right when we purchase something, your bank actually validates your transaction whether you have enough balance to make that purchase. So bank is acting as an intermediary and it actually validates that transaction. In the same way, in the distributed technology, we need to have someone who can validate the transactions. So there is a difference between the validation that is happening in the public and the private blockchains. In public blockchains, it's mainly done through a process called mining. So mining is Mining is kind of just like how you know about mining. We actually, for example, if it is a gold mine, people are actually mining for a piece of gold. They may or may not get it. So the same theories across, I mean, theories used over here when you're talking about mining. Once the transaction has been made, it must be verified by people called miners. In the network, actually, there would be people called miners. They validate the transaction. Once they validate the transaction, they will get something in return. They will usually in a Bitcoin network. Actually, what they do, like they validate the code. They they will declare that they have validated the transaction, and they will get some amount or bitcoins on return of that. So each of the time transaction is made, this is how it works. Whenever a transaction is made, it is broadcasted to the entire network. Just like how you do in the Facebook post, it actually broadcasted to the entire network. All the nodes will get to know that there's a transaction happen. So upon hearing this broadcast, these miners take a bunch of transactions. I mean, they will take, snatch all the transaction and validate that they are legitimate. For example, if I'm transferring some money to my friend, actually they can go and validate the transaction based on the network. So they will validate the transaction. They will put the record. They will put the record in the block, a block of data. Block of data is nothing but it's a bunch of transactions. Let's say transaction A, transaction B, transaction C. So all these three transactions they put in a block. So when the miners hear about the different transactions different times, so whenever the broadcasting is happen, there would be some latency, network latency, and they may not realize that it's reached over there. But everyone will go there, and all the miners will go there, snatch the transaction, and they will start working on it, and they will start building their own block so that they can add into the chain of blocks. So what they used to do, they validate the transaction. They declare that I have validated the transaction. They will get some money in return of that. They will put that block in the chain of blocks, putting a hash into that. I mean, they will put a key in that. They will put a hash key in that. So at this point, you are probably thinking, everyone is building different blocks. Then how will we agree upon a single common ledger? Because everyone is making their own blocks. But what does that mean? So that is why we have something called consensus of proof of work. So even though everyone is having their own block, they need to reach into a consensus. I mean, all the participant nodes, they have to reach into consensus saying that, yeah, this block, whatever the one of the minor A, like minor A or minor B, they have created a block. They have created a block of transaction. It has to be added to the blockchain. But we need to reach a consensus that yeah, let him or let her add that block into the blockchain. So that is about a beautiful protocol called consensus. So it's about miners don't need to build the same global block. They can each build their own block consisting of entirely different transactions. So all the participants will come to consensus on which blocks is included in the next item in the blockchain. So a miner may have block consisting of completely valid transaction, but the block may still fail to achieve consensus by a network. So here comes a consensus method like proof of work or proof of stake. It is mainly used in the Bitcoin network, Bitcoin terminology. Proof of work is nothing but every miner, whoever are participating in that transaction, whoever validating that transaction, they will try to solve a cryptographic puzzle. For example, you will get a cryptographic string of data, and you need to make I mean, you will try to solve a puzzle, cryptographic puzzle. Whoever solves it first, they will declare that yeah, I did that. I completed the validation and solved the puzzle as well. So they will tell the network that yeah, I have completed my work. So basically, consensus method are primarily, then all the nodes will treat this nodes will see this broadcast message from the miner saying that yeah, my work is done. So they will reach into consensus that yeah, then whoever completed the first, I mean, he's the one who did the block. Let him commit the block into the blockchain. So this type of validation and consensus are happening in public blockchains. I mean, bitcoins. The drawback of this validation or proof of work is that it needs enormous computing power. I mean, the cryptographic puzzle, it can take a lot of time to complete the activity. So it will take a lot of energy in that process. But if you see in the validation private blockchains, it is entirely different. It is called a selective endorsement. I mean, there would be some permission network in which consents can be active through a process called selective endorsement. In this case, non-users verify the transaction. The advantage for this business is to the only participant with the appropriate access and permission can maintain the transaction ledger. There are still few issues with this method, including threats from insiders, but many of them can be solved with highly secured infrastructure. So this is used in most of the organizations where they use private blockchains. There would be some people who will be validating the designated people who will be validating the transaction. Now we understood about blockchains. Now we'll see a typical use case. I'll take one or two examples, or maybe maximum 3 or 4 examples in which where we can use the blockchain technology. Let's say take the corporate bond. Where in the bank holding a corporate debt would like to pay when it's quickly on transaction validated by the client. Allow the corporate clients to see the payments made, provide government with oversight of the process. So how the blockchain will help them, like they provide a common ledger for recording all this corporate debt and bond. So it is available to the bank, corporate client, vendors, and governments. So they're all connected in the network. They can actually see that all the bond, whatever the bond they have created, the transaction details. So it's actually speed up the vendor payments, bigger net discounts, so eliminate the risk of accelerating decision making. This would be like, yeah, it's mainly for the business. I'll take one more small example. A smart device or refrigerator. Here in this case, let's say you want to buy a can of milk. What you used to do, like whenever yeah, in the morning, whenever you're going to make a cup of tea, you realize that uh, there's no milk inside your refrigerator. So you go to the supermarket and buy the milk. But let's think about a different scenario. You are all electronic students. You have got a device, RFID device, which is associated with a can of milk over there. You put the milk into a can, which has got an RFID or smart device. Whenever it is going to, whenever it's going to finish or it's about to reach in a threshold, it will create a message. If it is in a blockchain network, actually it can produce messages to a blockchain in which it can go to a producer. I mean, if it is a fresh milk, they can actually they can get a can of milk for you, and they can bring that milk to you. So it's basically you are actually in the supply chain management system. How it is, you can mix up the smart devices, for example, Alexa or Google Home, or you can tag your product with RFID, and whenever your a product is going out to your warehouse, whenever the gate opens up, it can send a sensor can sense that, yeah, the product is going out from the warehouse, and actually it can update a record in your supermarket or a stockist. So that is the beauty of once you that stockist get the alert or get the message, actually it can ripple to all the associated participants. It can go to the supermarket, it can update wherever the intermediary, it can supply wherever whoever participating in the supply chain network, they will get all those people will get that things. The updates. The benefit is business value from a connected technology, efficient network and supply chain, status transparent to all the network members. So that is how I told about supply chain management. When your product is going out from a warehouse, from a producer to the shop or to the customer, you can always track your product. Other potential cases include securities. The trading mechanisms, trade finance, loans, intrabank settlement, online gaming. I recently have read that Microsoft is doing the blockchain technology in the Xbox games. IoT, that is that would be typically you will be interested in. You can actually can create smart devices. I recently has seen that a person who is having a cup of, who is having a cup of tea, actually it's a smart cup. It has got a chip inside, and you'll go to the shop, a coffee shop, you'll buy the coffee, and you'll just like scanning your debit card or credit card, they will scan the cup, and the amount, whatever the amount of that coffee, or the shop person, that will be deducted from his account. So you can think about a smart device in which it can participate in a blockchain, starting from a producer to the customer. It can sense everything. For example, if you're creating a frozen food, or you're making a frozen food, you can with an IoT device, you can sense the temperature, the stock level, everything. You can actually can sense it. So that is why some of the big giants like Walmart, they're making use of the blockchain technology in their supply chain management system. And the retail bank have told mortgage verification, all the document verification is done by blockchain, public records, real estate records, vehicle registration, business license, and ownership records. So these are the with blockchain use cases. You can actually can go back and check what are the other use cases you can think of. You will have better idea. You will have better uh, vision for creating a use case out of that. These are the non use case I have thought, but you are free to go and check what are the other things. So these are the blockchain, some of the blockchain advantages. Blockchain technology allows for verification without having to be dependent on third parties. The data structure is blockchain is up and only. There is no reversing. It's once it is committed, it is committed. It's protected cryptography to secure data ledgers. It's all the transaction data are attached to the block after process of maximum plus verification. All the transactions are recorded in chronological order. You can keep that order efficiently. The transactions stored in blocks are contained can probably in millions of computers participating in the chain. The transactions that take place are very transparent. The origin of ledger can be tracked along the chain to its point of origin. In the case of supply chain management, from a producer to the customer, you can always track the product. Consent protocols are needed to validate the entity. It removes the risk of duplicating and fraud. With the smart contracts, you can put your business logics. These are the typical blockchain advantages I could think of, and these are the disadvantages. Slower process. It can some advantages can create a disadvantage as well. It can slow down when there are too many users on the network. So you need to have a good architecture when you are thinking about a blockchain. High energy consumption. The Bitcoin scenarios, they are, all the nodes are trying to solve the puzzle, so it will consume a lot of energy. Blockchain can sometimes be inefficient with poor architecture or how they operate. High cost. High cost, actually, when you make use of public cloud or the cloud infrastructure, actually, you can reduce the cost as well. Interoperability, there would be a lot of legacy systems used by different organizations. So when you are putting these things into that blockchain is put into a system, it may not operate as efficient as before. Harder to scale. So blockchains are harder to scale due to the consensus method, how they do that. Data is immutable. Because advantage can be a drawback as well. It cannot go back to the data is immutable because it has got a hashed value linked together. Still immature, a long way to go before it matures, and you need to find a good use case as well. Even in our organization, these years we have got a lot of R&D happening in blockchain. We're getting clients as well. So there are a lot of doing inventions, but yeah, the use cases, it changes from one client to another, and the integration with the legacy system can be very problematic. And as I told, blockchains, it's not a replacement for high performance transactions. So small organization, it's not ideal. If you're trying to replace a database, it's not the ideal one. It's not a replacement of messaging solution like IBM. Looking for a transaction processing replacement, it's not well matured, but still it has way to go. So these are the some popular blockchain platforms. I've seen it in Ethereum. It's kind of a Bitcoin. After Bitcoin, there is something created in a buzz in the market. Then it is Ethereum, Hyperledger Fabric, IBM blockchain. IBM is doing a lot of inventions or a lot of experiments in blockchain. They have got a lot of products in the supply chain management system, multi-chain, Hydra chain, Ripple. Ripple is kind of a um, it's a kind of cryptocurrency. R3 Corda, Open Chain, IOTA. So these are the some popular blockchain platforms. And yeah, so I had taken some references mainly on the IBM side, then blockchain dummies by Man of Buddha. I mean, he's also from IBM. Then Lisk, the video is full video is from Lisk. Then Wikipedia, 101 blockchains. So a lot of references from websites as well. So that's all about the session, blockchain session. So I hope you enjoyed it and you got some spark in that, so that you can think about more in future. This is my contact details. If you have any doubt, or yeah, if I can answer it, I can definitely answer it. You can note down my contact number. Yeah, so that's all. Thanks for listening to my 1 hour session. Hope you enjoyed it. If you have any questions, maybe you can answer to me.
Thank you, Prabhat, for your informative session. So participants, if anyone is having queries regarding today's topic, you can ask to our resource person now, or you can share that question in our chat box. You can unmute your microphone and directly ask to the resource person. Prabhat, one question just came in the chat box is that is it possible in blockchain to remove one or more block from the networks?
Actually, it's difficult, but there are some concepts called forking, in which you can make a chain orphaned altogether. For example, if you are competing for the same transaction, there are some ways you can actually can make a chain orphan and create a new blockchain itself. But you can't once block is committed to a blockchain, you can actually can't change that. It's immutable, can't change it.
Okay.
So once you block, once you remove it, you are destructing that chain altogether, because it has got as I told, it has got a previous hash value. It has got a previous hash value over here. So once you remove it, your chain is going to break it. So that is why it will be open, and you will create a new chain altogether. So actually, you need to fork it. So Swapna's asked me to edit a data which is being entered wrongly. No, that is the biggest advantage, and you can see it as a disadvantage. So once you committed a data, you can actually you can't do anything.
Any more queries from the participant side? Prabhat, I think there are no more queries, so we can wind up the session. Is it okay? Okay.
Yeah, that's fine. Okay, thanks all. Thanks, Mila ma'am and Alyssa and the UC College itself for giving me such a wonderful platform to give this presentation. Hope you enjoyed it. Thanks.
Okay, I now request Mr. Lijo Thomas, Assistant Professor, UC College, to deliver vote of thanks.
Morning to all. I'm Lijo Thomas, Faculty of ENC Department, UC College, Alua. Extends my hearty thanks to our resource person, Mr. Pravit Balagopalan, who shared a wonderful session on blockchain and currency transactions. Sir, thank you for being a part of our webinar series. We are looking for your support for future programs. Now, express my gratitude to our principal, manager, and HOD Mr. Akhil, and faculty members of our department to organize this event, a successful one. Lastly, I take this opportunity to thanks to all participants from the college of our department and other students and faculty members from various colleges to make this event a good one and a wonderful session. I hope all of you enjoyed the session very well, and you will get some ideas about the blockchain and its applications. Thank you, Prabhat sir, once again.
Thanks, Ledger
Uh,
sir.
Thank you for all.
Thanks,
Thank you
thanks,
for
all.
all of you.
Thanks
Thank you.
all, thanks all,
Nice.
students. Thanks all. Bye.
Thank you, Lijo sir. Once again, thanks to Mr. Pravit. So we can wind up the session. Thank you.
Thank you.